Alright, ladies and gentlemen, we're going to do a couple problems of 1.1 HW1 manipulating formulas. Now, if you notice here on the top of this Google form here, is that we start to do some park-like problems here. This is, on the top, is a park problem that's provided to us on the park website, where it says we have to manipulate the formula P equals 2L plus 2W and find the value of the length if we get L all by itself, aka we got to use our inverse operations to get L all by itself, and that demo problem above. But right here in front of us, I have problem number 1 of the homework, where we took in our formula here, lambda equals volume over F, and our goal is to get F all by itself, our frequency to be all by itself, where lambda stands for the wavelength between the crests of the wave, with the wave velocity v and the frequency f is given, as we see here in our problem. Lambda equals v divided by f. Our goal is to get f all by itself, and that's what we're going to do right now using our inverse operations. So, this is what's given to us here in problem number 1. Our goal is to get f all by itself. Well, now f is in the denominator. I want to get it in the numerator. So I'm actually going to do the inverse operation of divide by f, and I'm going to multiply by f to both sides. When I do that, it's going to be lambda times f equals v. So I multiplied by the frequency to both sides. Now divide by f and times f, they cancel out. That's why we don't have an f on the right hand side. Now this times lambda, if we divide by lambda to both sides, we then get our frequency all by itself. F equals v divided by lambda. And that's our goal. We found our solution. The frequency is all by itself. We have an F equals. So we multiplied by F here on the steps. We simplified. Then we use our inverse operations of dividing by lambda to both sides, and we found our solution. F equals v divided by lambda. And that's our answer. Now notice that a lot of our problems and formulas in life have different variables other than A, B, C, and different letters of the alphabet. On the first day, we handed out the Greek alphabet, because there's lots of Greek letters in mathematics, such as alpha, beta, gamma, delta, zeta, eta, theta, iota, kappa, lambda, mu, nu, xi, and all those other ones that are on the sheet. They're used a lot in mathematics, and we're going to see a lot of these in the upcoming problems that we do here in class and on the park. Don't worry, these are just symbols. Symbols represent a meaning behind it. Like the lambda means wavelength in this particular problem. The v in this problem means wave velocity. And f stands for frequency in this problem. But these letters could stand for other things and other problems. So that's why it's very important to read all the directions, so you know what each letter stands for, and you know what to solve for in a particular problem. Next up, we're going to do problem number 2. Alright, notice here in problem number 2, it's the same equation of wavelength that we're working with, where lambda stands for the wavelength, v stands for the wave velocity, and f stands for the frequency. Now our goal here in the problem number 2, it says, which formula shows how the wave velocity can be determined? AKA, we have to get the wave velocity letter all by itself. Now wave velocity letter is v, so our goal is to get v by itself. So, to get v by itself, we have to move this divide by f to the other side. So, we're going to multiply by f using our inverse operations to get f all by over to the other side to get v by itself. So we multiply by the frequency to both sides. We get lambda times the wave frequency equals v, which is our goal. That's our solution. We'll just rewrite it, make it pretty. V equals lambda times f. I just flip-flop the two. Because you like to put what you're trying to solve for on the left-hand side. And that's our solution for problem number 2. Next up, we'll do problem number 3. Alright, in problem number 3, we're talking about the formula for finding the angular velocity, which looks like a W there, and the measure of how quickly an object moves through the angle. This includes the final angle, theta, with a subnotation of F for final, for the final angle, with the initial angle, theta, with a subnotation of an I, which stands for the initial angle, and T stands for time in this problem. Now, we talked a little bit in class about what these little subnotations are about. So we're going to treat this theta F as one entire variable. The theta I is one variable, or one term, where the theta I stands for initial and the theta F stands for final. This is a popular formula that you'll see in science class. We're going to incorporate a lot of the science formulas into what we're doing here in math class. And we're going to practice manipulating them. So our goal here in problem number 3 is to find the final angle. So our final angle stands for theta F. So our goal is to get this guy all by itself. So first, we got to make that divide by t. We got to move the t over to the other side. So we times t to both sides of the equation. So we get w times t, or wt. That equals theta F minus theta I. So all I did was multiply by t to both sides. Then I simplified. Now we got to get theta F all by itself. So that means we got to add theta I to both sides of the equation. Now wt and theta I, they're two different variables. They're not like terms, so we got to say wt plus theta I equals theta F. Added theta I to both sides. And we got ourselves our solution. Theta F is all by itself. I'll rewrite it here. Theta F equals wt plus theta I. And that's our solution. Measure would be B. And multiple choice. Next up, we'll do problem number 4. Alright, here in problem number 4, we're still working with the angular velocity formula. And now our goal is to get the initial angle, the theta I, all by itself. So let's do it together. Our goal is to get this guy all by itself. So that times t got to go to the other side. So we're going to multiply by t once again to both sides of that equation. So we have wt equals theta F minus theta I. So that first step we multiplied by t to both sides. We then simplified it. Next up, remember our goal is to get theta I by itself. Remember there's an imaginary plus sign in front of that theta F. So we're going to subtract theta F, that theta final, from both sides of the equation. So we're going to have wt minus theta F equals negative theta I. You got to carry down, that negative belongs with the theta I. Now, we have to get rid of that negative. Well, we could do that by dividing by -1 to both sides. So we get negative wt plus theta F equals theta I. Or aka theta I equals negative wt plus theta F. And that's our solution. That's number 4. You're going to do number 5 on your own. Next problem that we're going to do is problem number 6. So this next formula is the displacement formula. It is the change in object's position from the origin. This includes the final position xf with the initial position of xi. So the xf and the xi, they're both two separate terms. Xf is a term and the negative xi is a term. So we're going to treat those as a whole. So we got three terms here in this problem. D, xf, and minus xi are the three terms in our problem. Our goal is to get the xi, the initial position, all by itself. So our goal is to get this xi by itself. This is our given. So there's an imaginary plus sign in front of this xf, so we use inverse operations, minus xf on both sides. So we have d minus xf equals negative xi. We're close to getting xi all by itself. We subtracted xf from both sides. Now we divide by negative 1 to both sides of the equation. So we get negative d plus xf equals xi. Now xi is all by itself, so that's our solution. I'm going to rewrite it to make it pretty. So xi equals xf minus d. That's just a commutative property like we talked about. You could flip-flop the two terms, the order of the two terms. I just like to have a pause in the beginning. So that's our solution. So go through the steps. We got our given, subtracted xx from both sides, simplify, then we divide by negative 1 to both sides of the equation, and we get ourselves the solution. So that's the solution for number 6. B as in boy. Next up, you're going to do problem number 7 on your own, but we're going to do problem number 8 together. Alright, sometimes in the world of mathematics, you're going to have two equations that could get you your answer, that you're desired, what you're looking for. In this case, in problem number 8, we have the formula for finding the buoyancy, FB. Notice there's two formulas to find buoyancy. One involves the volume of the liquid displaced, which has the V in it, and the other one has an HA, standing for the height of the floating object, and the A stands for the surface area of the floating object. Now P, which is found in both problems, is the density of the liquid, and G is also in both problems, which is the gravitational acceleration. Notice down below here what they're looking for, what they're asking you to do. Which formula shows how the surface area can be determined from the gravitational acceleration, the height of the water displaced by the floating object, the density of the liquid, and the buoyancy. So our goal is which formula shows how the surface area. So we got to ask ourselves, which one has the surface area? Is it the formula on the left or the formula on the right? In this case, only the formula on the right has the surface area, which is our A. So in problem number 8, we have to get capital A all by itself. So let's do it step by step. This is the formula that has the A in it. So PGH, all of this is being times by A. So to get A all by itself, we divide by P, G, and H, to both sides, the entire thing. All three of those letters, they're all being multiplied to the A, so we can divide by all of them. So we get FB divided by PGH, and it's equal to A. So we divided by PGH to both sides of the equation, and we got ourselves our solution. A is all by itself. A equals FB divided by PGH. And that's our solution to number 8. Next up, we'll do problem number 9. Actually, you're going to do problem number 9. We're going to do problem number 10 because that's tougher. A little more challenging. With problem number 10, Our goal is to find the density of the liquid, aka we got to get that P all by itself. Now notice in both of these equations we have a P. So we have to look at our answers here and our multiple choice. And notice, like, okay, there's multiple different answers for us. So that can't help us to figure out which one we got to do. So in fact, we actually got to get P all by itself on both of the equations and hope one of our answers matches up with one of the answers below in the multiple choice. Because obviously there's multiple correct answers of getting P by itself because there's P in both of these equations. So let's literally get P all by itself in both of these equations. So let's focus here on the equation on the left hand side. We have FB equals PGV. Our goal is to get P all by itself. So this is P times G times V. So we're going to divide by GV, those are the other two letters that are attached to the P, to both sides. So we have FB divided by GV equals P. P is now all by itself in this equation. Let's look on the other one here. We have FB equals PG H times A. Well, we have to get P all by itself, so we got to divide by G, H, and A to both sides. So you have FB divided by GHA. That gets us P. So we have two equations here where P equals two different things. And the one on the left, we have P equals FB divided by GV. And FB divided by GHA. So we look at our chances here in our multiple choice, A, B, C, and D. We notice option A is P equals FB over GV. So that's one correct answer. Now we have to look for FB divided by GHA to see if that answer is also available to us, which it turns out it is not. So A is the one and only solution here for problem number 10, given the multiple choice. Now it's your job to make sure you completed all the other problems that I asked you to complete. Make sure you have put your name, first name and last name, and then hit the submit button. Remember, if you have any questions about the stuff, come to Extra Help or ask questions during class. Alright, thank you for your time and have a good night.